Welcome to Unit 6, Equations. In Grade 7, we will solve linear equations using systematic trial, inspection, models, including a two-pan balance and algebra tiles, and near the end of the unit, our focus will be on the use of algebraic techniques to solve. It is worth noting that you may be able to solve some of the easier equations simply by observation, and you may question why it is necessary to go through the various processes outlined in this unit. However, it is important to realize that the models we use will facilitate a deeper understanding of what solving equations is all about, and the strategies, the algebraic techniques you learn to solve equations will carry over from year to year as you solve more complex equations that you will not be able to solve by observation only. At this point, you should have completed a word search to review some math terminology associated with equations and attempted the diagnostic assessment composed of 10 selected response items. In the first couple of lessons in this unit, we will review material that has been previously introduced, and revision should help you in understanding the new concepts that will be presented in subsequent lessons. So let's begin our introduction or our review by considering the question, what is a variable? Well, in mathematics, a variable is used to represent an unknown quantity or a quantity that can change. And we often use letters, N, X, M, P. We could use Greek letters like theta, alpha. These are some of the more common variables. In this unit, our focus will be on linear functions. For the first couple of years of junior high, you will stick to linear functions. But as you proceed through your high school mathematical career, you'll be introduced to many other types, including quadratics, exponentials, absolute value, sinusoidals, something to look forward to. But for now, we will stick with linear. And linear functions give you graphs that are straight lines. So there's a linear function, another one, and a third. The third point I want to consider here before we move on, what operation is implied when we have a variable immediately following a number? And of course, our four main operations are addition, subtraction, multiplication, and division. So when we have situations like this, 3y, 1/4 m, 10x. What operation is being implied? Well, that would be multiplication. 3y means 3 times y. 1/4 m means 1/4 times m. 10x, 10 times x. And we prefer this method of writing it. We are hesitant to go 3 times y. 1/4 times m. 10 times x. It's not that it's wrong, but especially in this last example here, when we put down 10 times x, you see how closely related this very commonly used variable is to our multiplication sign. Writing 10x helps to avoid that confusion. There are a couple of other ways that multiplication can be represented that are worth mentioning. There's the multiplication dot, so I could go 3 times y. Somewhat hesitant to use that one because it sometimes gets confused with the decimal point. The use of brackets is a possibility. This one I like using, so I could go 3 in a bracket, y in a bracket. That means 3 times y. I could also write it 3 bracket y like that as well. That means multiplication. But the preferred way of writing multiplication when you have a number and a variable is like this. So 3y, 1/4 m, and 10x. How do we distinguish between an algebraic expression and an algebraic equation? What is the difference here? Well, an expression is a mathematical phrase that contains numbers and or variables, but here's the key. No equality sign will be present in an expression. An equation is a mathematical statement where two expressions are equal and contains at least one variable. An equality sign must be present in an equation. We will examine some linear expressions, and we will examine linear equations. Let's review a little more terminology. Variables, numerical coefficients, constant terms. I'm going to give you a couple of linear expressions, and our task is to identify the variable, the numerical coefficient, and the constant term. So for 2m plus 4, the variable is m. The numerical coefficient, that's the number that comes directly in front of the variable. In this case, it's a 2. The constant term is what's off by itself, in this case after the addition sign, which would be a 4. It has no variable associated with it. In B, the variable is easy enough to pick out. That's a p. Our numerical coefficient is what comes directly in front of that variable, which is a half. And our constant term, the constant that's existing by itself over here to the left of the addition sign in this case, is a 5. Now we're going to do the same type of thing for a couple of linear equations. For 4x plus 5 equals 9, our variable is x. The number coming in front of our variable, directly in front, is a 4. So that's our numerical coefficient. And this time we have a couple of constant terms. We have a 5 and we have a 9. 5, 9. In B, our equation reads 3 equals negative 2 plus w. My variable, my letter here is a w. Now the numerical coefficient, be careful here. Directly in front of the w, you're saying, well, there's nothing there. In math, there's a number that's understood to be there, and that number is 1. You can, if you want, put it in there. More often than not, however, the 1 will not be placed directly in front of the variable. It is understood to be there. And for our constant terms here, we have a 3 and we have negative 2. The power of the equality sign. This is something in math we often take for granted, and it's important to note that the purpose of an equal sign is not just to indicate an answer. It's a symbol indicating that something is the same as another. It is equivalent. It is balanced. For instance, 1 plus 1 equals 2. You're saying that's pretty obvious. But think about what that means. It means that the 1 plus 1, that is the same, it's equivalent to, it's balanced with 2. If I give you 3 times 6, notice I've used the brackets here for multiplication. 3 times 6, that actually equals 18. So what I've indicated is that 3 times 6 is not the same as, it's not equivalent to, it's not balanced with 12. If we look at 10 over 5, or 10 divided by 5, equals 8 subtract 6. And the reason for that is that we should recognize that 10 divided by 5 is, that's 2, and 8 subtract 6, that's 2. So these two numerical expressions are equivalent. They are balanced. 12 plus 4, if we add those, we get a 16. 15 subtract 2, well, that's 13. Hence, using this, which means not equal to. 16 is not balanced with, it's not equivalent to 13. And we can put variables into the mix here as well. So if x equals 4, that tells you that, well, the value for x is indeed 4. 2y plus 5 equals 9. That's telling you that this side of the equation, the left-hand side, I'll often use LHS for that, is equal to the right-hand side, RHS. So those two sides have to be balanced. They have to be equivalent. Similarly, in this case, the left-hand side, 2n plus 7, will be balanced with The right-hand side, 3n plus 5. They will be equivalent. And now I'd like you to proceed to the next video in this lesson.